Okay, guys, so we are in the last day of notes here for this unit of the first part of sequences and series. So cool. I actually made a little mistake. I'll fix that before I print, but this one's just the ratio test. We're not going to worry about the root test. It's not on the AP exam, and it's really not that great. So I decided to skip it this year. So we're going to talk about the ratio test. The ratio test will show absolute convergence. So if your series converges by the ratio test, boom, it is absolutely convergent. Okay, so what you do for the ratio test is you take that a sub n and you do an a sub n plus 1. Then you go divide by the original a sub n, take the limit as you go to infinity, and see what happens. If you get out something that is smaller than 1, then that series converges absolutely. If you get something that's bigger than 1, then the series diverges. Absolutely. It doesn't really matter. It's just divergent is divergent. But if you get equal to 1, it's inconclusive and you don't know, try another test. Play again, try again. Okay, but this is what's really nice. And a lot of times you'll get out infinity for your limit. And remember, infinity is greater than 1, so that would be divergent. Okay, so let's go to the first example. And actually, before I do, a lot of times when I think to use the ratio test is when I see this hodgepodge of the n factorial and then the 3 to the n. So I see like a geometric part and then I see a factorial part. And so it's kind of hodgepodge together of different pieces. And so, excuse me, this is when I really think to try to do the ratio. Okay, so I'm going to take the limit as I go to infinity of this guy to the n plus 1. And I divide by the original. And remember, dividing by is the same as multiplying by the reciprocal. And the thing about this one with the ratio test is all of this with the limit is in absolute value bars. And I remember that because ratio determines absolute convergence. So anytime we're kind of using those absolute value bars, we're getting things absolutely. Okay, so then I'm going to simplify. Sorry, that was a 1. Remember, this is 3 times 3 to the n, and this is n plus 1 times n factorial. We practiced those a lot in our pre-unit. So I could cancel some stuff out and get what's left inside the limit. So my n factorials cancel, my 3 to the n's cancel, and I just have 3 over n plus 1. So as I go to infinity, this limit goes to 0. That is less than 1, right? That's less than 1. So this one absolutely converges by the ratio test. Okay, let's try the next one. Well, this would have been great to be a geometric series, but I have that in there instead of a numerical value, because that a times r to the n are number and number, and that n is not a number, it's a variable. So again, I'm kind of seeing this hodgepodge. So we're going to do the ratio test. So I'm going to set up the limit as we go to infinity of the next divided by, and I'm going to go ahead and do the division since this is kind of a fraction, but it's not at the same time. I mean, it's up to you. There's lots of ways. Divided by the original. All in absolute value bars. So we want to reduce, and I can see that this will reduce and just have it to the first. So that's the same as the limit as I go to infinity of now just 3/2 times that n plus 1 over the n. And this one is easy to see that they're growing at the same rate. So that's 3/2 and that's 1. So this would be just 3/2 over 1, which is 3/2. This is definitely greater than 1, so this diverges by the ratio test. So not too bad. Um, I think it's fun to simplify these personally. Okay, so on this one, I hope that when you see this, you first think to do alternating series test because it has the alternating series. And a lot of times an alternating series will show an inconclusive ratio. So I just want to show you what that means to be like an inconclusive ratio. And then we'll go do the alternating series just to review. Okay. So if I took the absolute value of this, note that that would go away. That's what happens when I take absolute values. So when I go look at the limit as I go to infinity, I don't have to worry about that part because it's all going to just be positive. So this is the next term times the reciprocal, because that's the divided by the original. And as I see this highest power, it's kind of like into the 1.5. And down here again, I get into the 1.5. And they both have coefficients of 1. So this gives me a 1. And that's the inconclusive for the ratio test. So the ratio test did not work here. So try something else. Well, let's go back and look at just the original. So when I look at this original, when I do alternating series, I like to write out my first few terms. So the first one here was negative 1 over 2, and then plus the square root of 2 over 3, and then minus the square root of 3 over 4, and then plus the square root of, where was I? 3, 4. So that would be, that would be 2 over 5. And as I kind of see these terms, and you can put it in your calculator if it's hard to see, but they are getting smaller and smaller as you go. I mean, look at 1/2 to 2/5, but these decrease in absolute value to 0. So this is convergent by the alternating series test. Okay, so let's look at this one. This one's different. What's different is we have the x's and the n's, which we will get to a lot in this next part, but this is kind of looking ahead, but something we can do. So it's a hodgepodge. What do you think to do? Ratio test. Well, let's go ahead and do that. So I'm going to take the limit as we go to infinity. N plus 1, 3 to the n plus 1 over x to the n plus 1. And then the original, we're going to have to flip. And then cross out everything that you can to reduce it. And you go ahead and do that. Pause me and then see if you get to where I get. Okay, so see if you get to there. So what's cool is this. When I take my limit, I'm taking it with the n. And the n's are growing at the same rate, so I would take the coefficients in front, which would be this. Okay, so it says, when will this converge? What would that x value have to be? Well, I want to know, when is that less than 1? And then I can solve. Where is 3 less than the absolute value of x? Or we could even think of that, we could flip-flop it, keep the bigger with the bigger, like that, and we get D. Not too bad, something you can completely do, but kind of looking ahead at the same time, okay? Okay, so that's the ratio. Let me see really quick. I have a little bit more. This I want to do in class together. It's a proof by induction, okay? So skip that for now. We can do that together. And then the last pieces I have are extra practice as well. So this on down is kind of some extra practice. And I'd like to do that with you in class as well. So guess what? You are done. You have learned all the tests that you need to know. I'm so proud of you guys, and I can't wait to show you the next part because it gets even cooler. You get to actually apply all of this. You had to get the basics down first. All right, see you in class.